Jordan? Okay. So, good morning, everybody. Just waiting for Jordan to set us up. We are live on YouTube. Not nervous at all. So welcome to our class this morning on setting up table saws and bandsaws. How to set up the machines correctly to provide accurate and safe work. So we've recently done a talk here about bandsaw and table saw safety, and a big component of that is how your machine is set up. And that's especially the case on the table saw and somewhat on the bandsaw, but your considerations between the two are a little bit different. As far as the introduction goes, my name is Dylan. I own a company called Ply Creations. I am a furniture designer and maker. I do bespoke furniture, usually once-off pieces, but I do have a website on which I blog every 2 weeks, and I'm moving in towards online and in-person woodworking education. So I have courses available on my website, and I blog twice a month. I try to do blogs as well. I do reviews and I do techniques and so forth in the blog, and I've got online plans on my website as well. So you'll notice there's a clipboard there. If you'd like to join up for my newsletter, I then send the guys who are part of the community a newsletter and special offers and so forth. And if you sign up, I've got a series of plans for jigs, push blocks, crosscut sleds and so forth that you can download for free. Okay, again, thanks to the guys at the Hardware Center offering us the opportunity and the facilities to do the training on their Laguna machines. And so what we'll do is we'll start on the table saw. I'll also show you some stuff on the whiteboard where it becomes relevant and why certain things you need to look at. So often what's the correct terminology here? Often woodworkers or often engineers become woodworkers. Show of hands, who are the engineers around here? Yeah. So something one needs to keep in mind, that even though you prefer to work from an accurate base, woodworking is hardly ever as accurate as high-performance engineering and machining. And if you do a cut and you're half a mil out from one edge to the other, it's still workable as far as woodworking goes. It's not precision engineering. Although the more accurate you work as a start, the easier your work is down the line as far as the quality of your joinery and fit and so forth. But sometimes if you clamp something hard enough, you can get it to glue together. But always try and start to work from an accurate base as you possibly can. But there are certain things you can get away with in regards to accuracy. And what tends to happen is we faff a lot with setting up our tools and how accurate we can set our tools to the point where we actually don't get to woodworking. And I've fallen in that trap. When I got my bandsaw, I don't have a Laguna, I've got another make. I spent almost 3 days setting it up, whereas effectively 2 or 3 hours would have been efficient. So oftentimes we want to get it as accurate as we possibly can, but at some point there's a point of diminishing returns. And you sort of just need to let it go. The other thing is as well is oftentimes on the bandsaw especially, some would like to go for as accurate a setup as you possibly can. But if you consider the use of this tool, at least in my workshop, is I process raw lumber on this one. I occasionally will cut out shapes with it, but generally I process raw lumber. So anything that is warped or twisted that I need to cut down to size before I take it to my jointer gets processed on this, because it's a safer cut to do here than it is to do on the table saw, because your wood can flex, pinch, and then come back at you in a kickback. So because I process raw lumber, I don't necessarily need it to be the most accurate tool in my workshop. So it depends on what you use it for. And the other thing that I use my bandsaw for is to cut bowl blanks and stuff like that. So if I get a rough round shape that I then put on the lathe to turn bowls, I'm happy. So, but once again, try and get it as accurate as you can, but not to the level of precision engineering isn't necessarily. What I like to do with my machines is when I do the setup, is I like to do the set and forget settings first. So that would be the settings that I don't need to spend a lot of time down the line to redo. And usually you would do that when you set up your machine, and you wouldn't need to do it again unless something goes wrong or you pick up that it needs attention. I like to actually service and maintain my machines once a year. I go through the machines, I go through my settings, and I look at everything and adjust whatever I found is an issue. So we will be looking at the settings on your machine from a global perspective, the big things, and then we narrow down to the smaller settings and the more important settings as we go along. Okay. So starting with the table saw. So does everybody here have a table saw and a bandsaw, or either one or the other? No bandsaw. Okay. No table saw either. Okay, so you're in a good place. We also consider this to be a demonstration. So, okay, really good machines these. This one in particular is a hybrid, and I'll show you what hybrid and cabinet saw and a contractor saw and what the differences are and how you set them. Also, I've been asked not to take these apart and screw up whatever settings is on them already. I was here last week and we've checked them. So generally they are correct. So I'll show you what you would need to do to be able to adjust it, and where we find major issues, I'll discuss how we can set it. I think this one's fence is out when we checked it last week, so we can actually have a look at doing the fence, and then we move over to the bandsaw. Okay, so now we need to start, guys. So that's the introduction. So if everybody can come closer. So there's always going to be a set of tools that you use when you do your setups, okay? A straight edge, always a good idea, okay? The longer the better, but the other thing is about a longer straight edge is the longer they are, the more difficult they are to make and less accurate they become. So a long straight edge is good, and the reason I'm taking this particular one is I want to bridge the full table. Jordan, are we standing in your way?
Yes, so you guys can just
Part.
around the table, just so there's a pathway.
Cool, so let's move that out of the way. Is that it? Okay, cool. So that's a straight edge is always a good idea, as accurate as you can get it. Then a set square. Now, as much as I sort of had a go at precision engineering, is as accurate as some manufacturers claim a combination square is. When I do my setups, I always prefer engineering squares. So I actually have a square that I got from a local retailer that stays in its box. I oil it every so often so that I don't struggle with rust or anything on it, and it stays in its box, and it only comes out when I do setups. So a engineering square is always a good idea, and I'll show you how I use that. You can use the electronic angle finders, can help you a little bit. I do find they're not as accurate as I'd like them to be. And then a source of light is always a good idea. And the reason you have a source of light is when you're using any straight edge against another straight edge, if you shine light through and you see the light coming through, you know you're not level. Okay? Now, another thing that one needs to consider is the fact that I think, and I don't know what it is in millimeters, you can see a light gap of around 1/1000th of an inch. Okay, so millimeters wise, it's also much smaller. So don't overcook your setups. Okay, be aware of what you are seeing, what you're looking at, and what is good enough for you to be able to do your work. So I always start with my table setups. Now, this is a narrow table. If you have a single form table, you don't need to worry about it like a contractor saw, for instance. But when you have wings on the other side of the table, it can cause issues if it's not set up correctly, and it can have you chasing around your tail. So let's say you're not getting a decent square cut. If you're doing an edge cut on a piece of board and you're not getting a square cut, and you keep circling with your blade and the blade's set up in relation to the tabletop, your problem may be here, okay? And it may be here. And the reason for that is, let's say that is your main table, okay, that your blade goes through. And now you've got a wing sitting here, and you've got another one sitting there. This edge here is what you need to pay attention to. That's where it's set up. Now, if a table wing slopes down, it's not too much of an issue. Because remember, when you do a cut, you put pressure down on that side. So that's not too much of an issue. However, if it slopes up, that is an issue. Because now your workpiece, as long as that workpiece is longer than your primary tabletop, as long as that's there, it lifts it up, and you're always going to get an angled cut. So these are the things that you need to take in consideration. And usually setting this up and leaving it be is fine. It doesn't really change all that much. And believe me, to get this set up absolutely perfectly can keep you busy for a couple of days. Yeah, been there, done that. Yeah, another one that has. The knowing smile. Okay, so another thing that I need are these. Finding that it becomes worse and worse as I'm getting older. And if another optometrist needs to tell me, well, at your age, it gets a little bit irritating. So this one is actually not ideal. So if you guys can come around, I'll show you what we're looking at. Now, immediately, if I do that, you can see that this one is way out. It's way lower. But remember, because it slopes down, it's not that much of an issue. Now, there's screws here that you can loosen. So there's one here and there's one here. You can loosen them, pop it up, and you're done. Okay? But you'll also notice that if you can see the light through, that this edge on the wing is higher than the table, and I think the same is on this case as well. So those two tables needs to be brought down flush with the top. Now you can feel here, always use your fingers, okay? Not while the blade is running, by the way, okay? Also, safety-wise, guys, whenever you work on a machine, please unplug it first, okay? I'm a little OCD. So not only do I unplug it, I actually switch it on and switch it back off just to make sure it's off. Okay. So this would be your first, let's call it a macro adjustment, for lack of a better word. And this is something you'd need to pay attention to. So whenever you're cutting anything here and your workpiece is past here, this is going to pop it up slightly. You might be a half a degree off. But that half a degree may be big enough if you're doing a small box. If you're doing a dining room table, you might never notice it. If you're doing a jewelry box for your wife, you may have an issue. Because the smaller your work pieces are, the more accurate you need to work. So here, you would need to pay attention to setting it up correctly before you do anything else. With a little bit of sag on this side, I wouldn't be too worried, but I would go through a lot of trouble to get this flush, or even slightly lower than the rest of the table. Okay? So that would be your first macro adjustment that you would need to look at. Now, different saws have different solutions. So mine, for instance, my table saw is, I've got a cast iron wing on either side. Okay? Now, those cast iron wings are really tricky to do. And I've tried everything, to the point where I've actually dimensioned lumber, got the lumber squared, clamped the lumber to my main table, and then clamp the other section to it as well, on edge, because you don't want your wood to flex, so don't use it on the face, use it on the edge grain. So I had it on, clamped everything together, and then brought it all together, and that seemed to work. Okay, but at some point, you get what you pay for, and on certain machines, it's not as well machined as on other machines, and you may find that on the older machines it also may be the case. The machining is not done so well that you're going to get it absolutely perfect every time. So sometimes there is some level of compromise. Okay, so that would be the first macro adjustment that I look at. And that would be apart from actually setting it up as straight and square as you possibly can when you put it together, when you get it out of the box. Okay, but the one thing you want to avoid is this, at all costs. Okay, because when you start with your finer and your more micro adjustments, that's when you're going to start chasing your tail. Because you're going to keep working here and fiddling here and shimming trunions and doing all kinds of weird things when actually it was a very simple fix. And usually what's the case is you have an issue like this and you struggle here about 5 or 6 days, 2 or 3 sleepless nights, and then the light bulb just goes on and you go back and say, okay, but this is out, and then you adjust it and it seems to work. Okay, it happens. Any questions so far? Okay. The next thing that is very, very important from there is you've got your mitre slots on either side. Now, if in effect, if it was machined properly, those mitre slots should run parallel to one another. Okay? And because they run parallel one another, of course, on your mitre slots, there's nothing you can do about it. That's the quality of machining that your machine comes to you in the box. But after you've got your mitre slots, it's very important that you then align your blade, your fence, and then lastly, your mitre fence. Mitre fence for me is probably the least important of them all. It's because I very rarely use my mitre fence, and instead of using a mitre fence, I may occasionally use my crosscut sled, and on a crosscut sled is during the building process, that's where your alignments take place. And even if your blade isn't necessarily parallel to your mitre, on a crosscut sled, as you can set up a crosscut sled to still cut square to a certain extent. But most of my cutting on my table saw is ripping, and in some cases and in some workshops, the guys don't do a lot of cross-cutting because they have chop saws that they use for their cross-cutting. But in my case, I don't have a chop saw, so it's important that my crosscut sled or my mitre fence is then set up as accurately as I possibly can. And there's a couple of ways to do that. Okay, shall we move on? Now, before I go 90 degrees to the top, as far as my blade's vertical adjustment goes, I want to make sure that it is parallel to my mitre slot. That's really, really important. Always also remember that if you use a mitre slot to do the adjustment on your blade, that you always do all your other adjustments from the same mitre slot. Because if you then adjust your fence against another mitre slot, you may have issues if there was an issue with the manufacturing. Because you always have to work from the same standard. So always work from the same mitre slot and go from there. Good morning. There's a few tools that you can use. So one of the ways that the guys actually do it is they will have combination square. You set the combination square against something that you have in your mitre slot, or you may even ride the stock of your combination square in the slot, and then you adjust your blade of your combination square. It's a bit of a tongue twister this morning. The blade of your combination square you set up so that the blade just hits the blade here. Okay. Jordan, can we get a combination square? Not seeing one immediately. Sorry, I just wanted to show what I mean. No, there isn't one. I find it fiddly and it's a little bit problematic. Have you got one on the shelf? No, they're all set. Thanks. All set squares. Okay, but to get a more accurate and consistent result, it's a good idea to invest in something like this, something similar. I'll show you my own, what I use, but that is a very useful piece of equipment. It uses a dial gauge, and it does measurements in millimeter-wise 0.01 mil, so which is really good enough in regards to accuracy goes. If you are going to purchase a combo square, these are one of the more accurate ones. So what they do is, you'll see there that it rides against that edge of your miter slot. And what you then do is you bring your blade out. See, so that's where the problem is consistency. This is where this is really tricky to use, because you have to use it in a consistent manner. So now I want to measure from that edge of my miter slot to a tooth on my blade. And I move that out.
Actually to the tooth, not to the blade itself.
No, to the tooth. Not to the blade itself, because the blade can actually be warped. So the panel of the blade can be warped. Not the panel. I'll think of the correct term now. But so the blade itself can be warped. So you always measure from a tooth. Okay, because remember, your tooth is also what does the cutting, not the blade. So your teeth need to be in line. Okay, once again, you get what you paid for. Some blades are better quality than others. Then you need a marker. So that's another thing that so I've got all my stuff here. So you need to mark the tooth that you work from. You always work from the same tooth, and you need to mark it. So I prefer to measure from a cutting tooth. Now you'll see the teeth are positioned in a cutting edge on this side. They're offset.
One in, one out.
One in and one out. So I always want to measure just the way I prefer to do it. I measure from a tooth that is in towards my combination square. So I'll mark that one. So you mark that one's position. Okay, so now you don't get confused. So now you have to set up your combination square and move it out until you slightly hit.
Just touch.
Yeah. Can you hear it touching? Okay. But now, that's where I want to be. Now I tighten it. Still touching. Often when you tighten it, it offsets the blade, and now it's not touching, or it's touching too much. Okay? Now, I'm hitting it there. You can hear the sound. Now I move the tooth, that's the one I've marked, over to this side, and I want to hear. See? It hits it much.
Much more interference.
Yeah. You can hear. So that's maybe a mil, half a mil over. So that can keep you quite busy, especially when it comes to setting the blade and the combination square, and then moving it back and moving it forth. And often that edge there isn't necessarily square to the rest of the blade. So also where you hit the tooth here becomes important. So it can be done. I do find it's a little bit fiddly. So yeah, I don't prefer this method in particular. However, what I do like is using a dial gauge. So this particular dial gauge has actually been set up for this machine. So, and you have to, of course, you have to check it on the front and on the back of the blade, because remember, you want to see if it's parallel to the miter slot. Now here, that is now in the miter slot. I don't have to worry about where I position it. Am I holding it flat? Am I always referencing against the same reference edge? So I don't need to worry about all of that. It's set in here. One of the issues that can possibly happen with something that sits in a miter slot, even though the miter slots, I think standard size is 3/4 of an inch, 19 point something mil. Even if it was made in a metric factory, it's always going to be 3/4 of an inch, I think. So because of that, whatever you put in the slot can move and wobble, which means you're not parallel completely. What's nice about this particular one is you've got 2 grub screws that you can adjust, and those have got 2 ball bearings, and you can set tension within the mitre slot. So what you don't want to happen is once you put it in and you do, you don't want whatever you put in the mitre slot to wobble like this, because that will change your distances. Okay. So this one was adjusted last week, and then you've got different depths on mitre slots as well. You want this to be flush to the top, and this one's just got screws that will stop that from happening. So they just depth adjusters that stop that from happening. So it just provides a certain level of consistency which you wouldn't otherwise have. You loosen that particular screw on top, and then you set it so that it hits the tooth. Okay. So now also you need to find the highest part of the tooth, because you'll see that the tooth slopes. Where is it? Make sure I use the right one. Last time I used a board, I used a permanent marker. See this, Jordan? Okay. So the tooth will typically, okay, slope out. You want to hit that area there. Also, often the tooth, if you look at it from the front, it also slopes to the other direction. So you've always got a compound curve where the two meet. And you want to get the highest spot. And you always want to hit the highest spot. So what I wanted to bring is you can actually get different tips for these dial gauges. And I've got a tip on mine that looks like this. So that one you'll see runs like this. Okay? So you've got a very small area that needs to hit a very small area. They can be tricky to use. So other one I have is actually flat. And that screws into it. So I've got a much bigger surface here to hit that small area there, which makes it a little bit easier. Getting those tips, though, is a bit of a trick. You have to go to a specialist shop and they order it for you. So finding the highest spot there can be a little bit tricky. Okay, so that would be, I would consider that to be the highest. So if I move that back and forth, so you get a ballpark. Then you set your 0. So now we dialed into 0. So what's nice about the dial gauge here is the fact that even if I start there with my settings here, which is going to be further away, I can still set it to 0 and measure from there. So that's quite a useful thing to have. So that is now set to 0 to the front. I pull that out just to get the probe out of the way. I move my tooth around, the one that I've marked. I move my dial gauge and I drop it in and I find the highest spot here, and you'll see by the flex there, okay, I think it's 0.05. So 0.05 mil, if you listen to the blade on the combination square, it definitely made more of a noise. But that could be the edge of the blade, the front edge here not being square. So am I hitting the blade in the right position? Is it the square? Is it machining on the square? And so forth. So that for me will work in a pinch. But if I want to really set up and dial in my table saw, I typically would use something like this. And 0.05 mil is not millimeters, sorry, is close enough. Really is close enough. Okay. I would go anything higher than half a mil and more. Yeah, half a mil and more, probably. I did a boardroom table last year, and the boardroom table was 3.5 meters long. And just for giggles, I measured the width of the table after I did all the machining and sanding and planing and so forth. And I'm a what they call a hybrid woodworker, so I use both hand tools and machines. And I was hand planing the edges and getting everything together. And over a length of 3.5 meters, I was out by a mill on the other side. I was really, really chuffed with myself. So to a large extent, half a mil and more, I would probably pay attention to. It depends on how accurate you want to work. If you are doing a lot of large-scale projects, that wouldn't make so much of a difference. If you're doing a lot of small-scale projects, you may find that half a mil may be too much, and then you can further adjust it. So the beauty of this system is the fact that you can really adjust to your own preference without needing to go overboard and trying to get it perfect. Because you may also find that you may get it very, very exact close on one blade, but another blade you may not get it all that accurately, because that's then a reflection on the manufacturing of your blade itself. But generally, you can get it quite close and you can get it quite consistent. I, for instance, and we'll do it when we discuss the fence, I actually don't use the measurements here. I always use a rule between my fence and my blade, because I'm also consistently changing blades and my tooth curve isn't all the same. So now I have to adjust every time to zero, get back to zero, and I find it's just too much of a waste of time. So I actually measure with the rule between the tooth and my fence. I find it to be faster.
My table saw isn't so fancy. I've got the normal Bosch blue, the small Bosch blue one, and the tracks are not the same size as this, and it's got, the tracks are sort of half covered.
You make your own.
I bought a jig the other day, that I thought it fit, like the fingerboard, and it just wouldn't fit in. So I was thinking, what's wrong with mine? And I noticed all of these are bigger, and mine's enormous.
Miter slots aren't always the same. So as far as table saws goes, often you will find that it's standard at 3/4 of an inch or 19 and a bit mils. But when you get into the contractor saws, between the DeWalt's and the Bosch, and they're not all the same. The one thing that irritates me about my bandsaw is the fact that this one uses a standard miter slot. My bandsaw doesn't use a standard miter slot, it's much smaller. So any cross-cut jigs and stuff that I want to use, or even a miter gauge, because everybody brags you can use a miter gauge on a bandsaw, I can't use any miter gauges on my bandsaw. I need to make my own, because you likely need to make your own. And in this case, I have a solution for you. So before these fancy jigs became available, I made my own. So you get a magnetic base for something like this, and so what you can do, okay, it's a little bit fiddly. This happens to me every time I try to do this. So what you do is, so you get the magnetic base. So the thing is about moving your dial gauge from the one side of your blade to the other side of the blade, you need to have some consistency. Okay, and the only way really to get that consistency is to have something in the miter slot. So I made myself a miter slot rail, and it's the same way as you would do them with hardwood or plastic or something like that, that you would do for your crosscut sleds or any other jig you would want to use. Put it down on a base. I then put in a threaded insert, and that then screws into there. So I have that level of consistency.
So I've got a dial gauge. They have this nifty arm that you attach it to.
Yeah, that's a magnetic base. So you buy them. They're not cheap. They're not expensive.
What do you call the magnetic base?
Because it's got a magnet that goes with it. These are very useful.
So that's one whole unit.
That's supposed to be, yeah. So, but now remember, if I then try to use this on the tabletop, I no longer have consistency from front to back. And that's why that's got a standard, I think it's an M8 thread. So you just do the threaded insert, and because I've attached everything together, effectively I get what we've just used.
Africa, the dial, is the base also from?
Yeah.
Are they accurate enough? I bought a freaking dial from China. I'm not sure I can trust it.
They're accurate enough. Once again, you missed the beginning of the talk. It's really a decision against. It's not precision engineering. It's woodworking. So it's close enough. Generally, it's close enough. Okay, and I use this kind of setup for everything. And what's nice about this base, I've also got lights that are mounted to this base that I use when I do turning. And what you can do is you can use this as stops on your table saw when you're working. You want consistent cuts, or on a what do you call it? On a router table or something like that. You can use this as a stop. If you want to cut strips of different sizes and so forth, you can always use this as a stop. So it's quite a useful tool. Yeah. So that's very useful. So this is the system I would use typically in my workshop. And then it works just as well as that. The thing is that by the time you've bought the dial gauge and the magnetic base, you might just as well have bought that, the other system. However, this could be considered, and you can set this to do distances and that kind of stuff, and you can get a magnetic base and move the dial indicator, but this is sort of a one-trick pony kind of thing. Whereas this, I remove it, I use the base, and I use the dial indicator for all kinds of stuff. So it's really a case of what you need and what you want to use it for. But yeah, you can use it for whatever. However, this I need to fiddle around with and get the adjustments and get the position so that they don't interfere with one another. And so this can be a little bit more fiddly as a start to set it up. Whereas this one, you just pop it and adjust that screw and you're done. And once you've actually made this adjustment, we did this last week when I came and tested everything just to make sure that everything works for today. It's set up, and it only needs to be set up once. So you just take it out of the box and you use it. So it's really a case of you decide what's going to be easier for you. Okay. So this is what I would consider within specification.
And adjusting that blade, is there like a vernier adjustment underneath, or is it bolt down that you got to loosen and then shift the whole thing? Or does it depend on the saw?
Depends on the saw. So that would be the next thing we need to talk about. So it really depends on the saw. So some saws you cannot adjust. My first table saw, I bought it from a local shop, whom I'm not going to mention, and I struggled with it for almost a week. I took it back and I asked them for my money back because I could simply not adjust the blade parallel to the mitre slot. Nothing that I did worked. I tried jigs, shims and all kinds of stuff, and I simply could not get it to work. And it was a manufacturing fault. So it really depends on the table saw. So some table saws are easier than other table saws to adjust, and the manufacturer will make it easy for you. Others are a little bit more difficult. So let's start with the big boys. Let's start with what we call what is called a cabinet saw. Now, the definitions of saws are really dependent on how they were put together. So a cabinet saw is your whole motor assembly and everything that goes around that is attached to the cabinet, to the base, to the box. Then the tabletop is also attached to the box. So if you need to adjust your tabletop or your saw top, you can loosen the top and do that particular adjustment without having to touch the motor assembly and the trunnions where everything is being connected. That's a cabinet saw, and that's actually what defines a cabinet saw as well. It's the machine's attached to the box, and the top is then attached to the box as well, and you can move them independent from one another. So how would you, okay, so let's go through the saw types, and then I'll show you how you would want to do that adjustment. The second one is what they call a hybrid. This one is a hybrid. So a hybrid is really a combination between a cabinet saw and what is called a on-site saw or a job saw or what they call a contractor saw. And the reason they differ is the whole motor assembly and trunnion and everything is attached to the top. So you need to loosen the motor to be able to adjust the motor and where the arbor, the shaft that your blade sits on that gets turned by the motor is called an arbor. Where the arbor sits in the motor then needs to be adjusted in relation to the top. Okay, so that is your contractor saws or your job site saws. A hybrid saw combines the two. You've got a closed box, which is effectively here more or less for dust extraction, okay? Because a closed area can better be extracted than an open area. So your box sits here, but your motor is still attached to the top, okay? So you need to loosen your trunnions, and this one is the case. That's why I was actually quite happy that when we checked this one, it was set up correctly, and it gets set up from the factory. But what you need to do is you need to open one of the sides, one of these sides, and then you need to get in under and then loosen it, and then you can imagine it can get quite fiddly. Where a normal contractor saw is usually open legs and so forth, and you can get in underneath and you can do the adjustments. So depending on your machine, you would then need to make the necessary adjustments. So it's really important that you check where your motor assembly and the mechanics is attached. Is it attached to the box, the base, or is it attached to the top? If it's attached to the top, you need to loosen the motor and adjust it. Okay? If it's attached to the base, you just loosen your top and then adjust your top. And any questions around that? Okay.
Is it usually like a straightforward, like 4 bolts?
Yeah, it's never straightforward. So setting your blade parallel to your miter is checking it is a hell of a lot easier than doing the adjustment. Okay? The adjustment can keep you busy. But there are certain things you can do to make it a little bit easier for yourself. And I'm going to show you how you do that now. So irrespective of what kind of saw you have, there will be 4 screws generally, unless it's some or the other weird system. There's 4 screws generally that you need to loosen for you to be able to do your adjustment. So let's say you're looking at your table from the top. Okay, so that's your tabletop. And let's say that's your blade. Okay, you're looking at your blade. Now, if you take your measurement from the front, so let's call that the front, and let's call that the back. And let's say, here's your miter slot, that's going to be your standard miter slot. So here, for argument's sake, is 15 mil. Okay, I'm just saying that distance from there to there. It's probably going to be, it's going to be longer. But let's say, for argument's sake, that's 15 millimeters. This one is 16 mil. So from your miter slot, it's in this direction here. It's further away. Okay, still with me? Now you've got 4 screws, or 4 bolts. One there, one there, one there, and one there. If it's the trunnions, if it's a contractor or job site saw, the screws will be here because the motor is attached directly to the bottom of your top. But the premise is the same. Now what you want to do is, you either want to move that section away or that one closer. Agreed? So the best way to do that is you loosen your bolts, okay, so that they're just loose, and then one of the bolts you retighten slightly, just so that it catches. Okay, and you can do the same on the others as well, but one of the bolts needs to be relatively secure. And what you then do is you either tap one of the corners of your table and you swing it in around that pivot point. Because what you want that pivot point to do is maintain the setting that you want, or the distance that you want, and you want to swing the other part of your table either closer or further away. And it's really dependent on your table saw or your machine that you have with you. In time, as you said now, alluded to, it's a simple process, but it can really keep you busy, and it can keep you busy for a long time, especially if you don't know this particular concept and say, okay, I'm going to loosen all my bolts, have them loose, and then I'm going to move parallel in and out, and guess what? The moment you tighten them out, you flex the table and you change your adjustment again.
It's such a fiddly thing. Why didn't they just put some dials on for you?
Why would anybody want to make your life simple? Come on. Part of being a woodworker is struggling. Okay? Struggling and fixing mistakes. And another thing that we do as woodworkers is, I made that cabinet. So because we're all woodworkers, I'll come and tell you all about all my mistakes. We like telling other woodworkers about our mistakes and what we did wrong and what have you. I'll get a knowing nod there in the back of the class, and that's typically something we do as woodworkers, and we like to suckle, we like to struggle. So it complicates manufacturing, and that's the main reason. And for you to be able to do adjustments, remember, you need to have a fixed place here. Let's say you've got an adjustment screw. Now you have a fixed place. Now you have an adjustment screw that you feed in and out to put pressure in, to move it in or to bring it back. And that just complicates construction a lot. So a tool that is already relatively expensive then becomes significantly more expensive. And there's a certain level of precision that is required in something like that as well. And that's the reason. Look, it's a simple setting to adjust, but it can be a frustrating adjustment to be able to do. And what you then do is you use a rubber mallet, you tap, 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 you tighten, you measure. Ooh, it's out. Go again. And that's how it works. Oh, I'm tapping, but last time I tapped it 4 or 5 times and it didn't move all that much, so I'm going to give it a harder tap this time around. You whack it and you've gone too far. And that's something that happens. And this is how you get to know your own machines and your own equipment, and you know how far you can go and not go. Guys, once you've done it, check it once a year, but you generally wouldn't need to adjust it every 2 or 3 months. Really, you wouldn't. Unless you are really, really pedantic engineer.
You could change a blade, put a new blade in?
No, wouldn't necessarily, no. Because you've adjusted your whole motor assembly. Now, you are putting some level of faith in the manufacturing process of the blade. But generally, no, you wouldn't need to do it. Unless you go for really, really cheap blades. And considering the cost of blades these days. But then again, even the cheaper blades are made to a higher specification than they would be quite a few years ago. What you can do every time you adjust the blade, of course, you would need to check 90 degrees to your table. And if that is consistent, as well as your 45-degree cut or your mitered cut, and then if you want to adjust this, because your curve width will differ.
Out of curiosity, if you've got one of these fixed fences, like I think the fence on this one is off by like half a meter, length or something. Like my fence is a flimsy-ish fence, and every time it tightens, it's kind of skewed. What's more important? For me, it's easier in mine, for instance, to adjust my fence to match the angle of the blade, but that still doesn't match the angle of the
Miter slot.
of the slot. But I mean, if you're somebody that uses the fence more than you use the slot, would you adjust the blade to suit the fence rather than the slot?
So no, you always use the slot. Because your blade is parallel to the miter slot, if you then adjust your fence, by definition it should be parallel to the blade.
Is the fence always adjustable?
Most of the time it has to be, yeah.
Even these ones?
We can have a look at them, but they should be. They should generally be adjustable. Some fences are easier to adjust than others. And of course, when you put your fence in and you tighten your fence down once you've got your distance from the blade to the fence, so the width of your cut, it has to pull straight. It has to pull square. And some saws are better at doing that than other saws. And sometimes certain saw manufacturers have a very complicated system of where they've got a rail here and they've got a rail there, and then it's offset to the one side and not straight on the other side, and when you tighten it, it doesn't straight properly. So this is how you get to know your tool, and you know that, listen, if I adjust my fence and I pull it tight to set my distance between the blade and the fence, you know that you're either offset on the one side or the other side. So for instance, my fence, when I move my fence towards the blade, and we're going to do the setting on the fence as well after we've discussed the blade. But as I bring my fence in, the back end always lags to the front. Okay? And I'm always very sure that when I tighten it back that I see that movement come in. Also, what I often do is, because I use a rule between the blade and my fence, is I will get the setting or my distance, and as I tighten it, it will either close up or be further away, so I'm not at my distance. And I know how much tension I can put on the handle so that I can tap it across with my fist, either the one side or the other side, and get my exact measurement. So it's really a case of getting to know your tool and knowing what it either can give you or not and where it lags. No. Look, the more money you spend on your table saw, the easier it is to use in regards to accuracy and consistency. Guys, and if you're out by 1 mil, always be out by 1 mil. So if you find that your saw, you want to use 200 mils across a cut, but it's only 19.5, don't do one piece 200 and the other one 19.5 and the other one 19. If it's out at 19, always cut it at 19. If you make a dining room table and your width is, let's say you're doing it 1 meter wide and it's 999 millimeters, no customer nor yourself is going to stand here and say that's not 1 meter wide, because you're not going to see it. So if you have inconsistencies, keep the same inconsistencies right through your project, rather than measuring exact. For instance, a cabinet like that is, if I do the middle section, okay, I don't cut the middle section from my plans. I cut the middle section from actually measuring the distance between the top and the bottom, because I don't know what inconsistencies I might have built into my joinery. So you measure from the workpiece. So that can become a really long discussion, and how accurate is supposed to be accurate. But after we've set the blade parallel to the mitre fence, to the mitre slot, we then move to the fence, and after that we go to the mitre gauge, and then we look at, is your blade square to the tabletop? Okay, but yeah, this is a very important concept to understand, is loosen the bolts, tighten it back so that it just catches, okay, and then your pivot bolt, don't crank it so that you tear the bolt head off when you do the adjustment, okay. Guys, I used to be a service engineer. I used to fix medical machines, and how tight do you tighten the screw? You tighten it until it cracks, and then you do half a turn back. That's always a joke that we had, but over-tightening stuff is also not a good thing. But this can keep you quite busy, because remember, your tabletop is tightened to a base, and even though it's metal, it will flex. If I use a hand plane, and I use a lot of hand planes, I can flex my metal hand plane so that it isn't flat on my work surface. I can flex it. If I sharpen my blades and I flatten the back of my blades, I can push too hard onto my stones so that I don't get it flat, because I'm skewing the blade. You can actually flex metal. And the moment I tighten this, it flexes again, and therefore you need to remeasure. So tighten, set, measure, go back, tighten. But remember, this concept is really important, because that will save you a lot of time, really a lot of time. And now remember, if I want to swing this over, which one do I tighten? If you can tell me, I'll buy you a cup of coffee, because you can either have that one and pivot around that corner, or you can have that one tightened as well, and you still have a similar pivot. Okay? But it depends on where the center of your radius is when you pivot.
I would probably distance on the side of the opening of the blade as a guideline for this? Because if it's very close to the opening on the one side, you want to remove the bit in the other direction.
You need to explain to me now. I'm not catching what you're meaning.
No, I mean, like my saw, out the box, when I had a look at it, I could see that the gap on the one side here was much smaller than the gap on the other side.
Yeah?
So I would have moved mine over to sort of...
Yeah. So that's quite risky in the sense that you've got all kinds of parallax faults and stuff in regards to when you eyeball something. And that's why you need to have the consistency of a measuring tool. So you take that eyeballing, because remember, there's no guarantee that this slot here was machined correctly.
No, that whole thing wasn't right.
Yeah.
I mean,
So
you take it out, you look at it, you go, that's skewed.
yeah, but now remember, be careful that you don't consider your blade skew and maybe looking at a poorly manufactured component. Because you look at the component and you say, okay, that doesn't look straight, but how consistent is that component specifically? You have to work from a consistent standard base, always. So eyeballing it from a part that is loose and could be manufactured is going to cause you some problems. You need to use a fixed reference. Datum all the time, correct. I'm going to keep teasing you because you're the engineer. It's a very engineer term, but very correct. So that's the blade, okay? We need to carry on, otherwise we're not going to get to the bandsaw. Because that's a bit of a black art, that one there. So now we go over to the fence. So we drop the blade. Remember, same reference, always. Okay, there's the fence. So this is what is called generally a Bessemeyer style fence. So you'll find these styles of fences on most table saws. And you might have noticed when I tighten it down, mine does the same. Pops it in on the side. And what's nice about the Bessemeyer fences, there's no reference. What a lot of the cheaper manufacturers do is they also use this as a reference, assuming that when you pull everything straight that it's going to pull against that side and that side, but you've got friction here. So often it gets stuck and it doesn't actually pull across. Whereas the Bessemeyer fence, that goes into a slot and this is quite wide. Okay? So as long as this is perpendicular to this, it will pull straight. And that's why I like them. I really do like them. So this one is actually out. That's the pen. I'm not trying to break your machine. So one would be tempted to move over to this particular slot. Okay? But as one of the students mentioned, you want to use the same datum. Sorry. So I'll move that up until my needle starts moving. Pop it, and you'll see how much it's actually changed. Find 0. Now here we don't have to fiddle around with finding the highest spot. Okay? Because effectively this should be flat and it shouldn't have any high or low spots. Now if I move this across, you'll see it increasing. Because this one is out. Okay? It's almost 0.01 moles. Now, your fence can be slightly not parallel. And actually some guys will go and set it specifically to be out of parallel. And the reason they do it is for safety. And it's a little bit of a school of some believe the one to be correct and others believe the other to be correct. So once again, there's your saw, there's your blade. And let's say this is your fence. If your fence is going to be out of alignment, out from the mitre slot, you want this, once again, this is the back of the blade, this is the front of the blade. If you want it to be out of alignment anywhere, it's here. Okay? Some believe that if you have your fence slightly away from the back of your blade, it minimizes the risk of your blade actually pinching the workpiece and shooting it out back to you. So it minimizes the risk of kickback. Now typically, this is a good idea if you've got a very old table saw that doesn't have a splitter or a riving knife. because that mitigates the risk of kickback happening because it doesn't pinch the workpiece and shoots it back at you. I don't personally, I agree with the fact that it's safer, but personally, me being pedantic, I want it parallel front to back, because sometimes in my head, I believe there's a risk that you can push your workpiece back into the blade there, and if you don't push through your cut all the way, you may not have your workpiece parallel front to back. So there is a risk in that, okay? But once again, we're not talking millimeters here. We're talking a mil and a half, not much, okay? However, what you do not want, and this is the case here, you don't want your fence to be going into the blade. And this is the case here. This is what's happening here. So this one I would adjust. And it's really easy to adjust. We can quickly do that. How are we looking for time?
Sir, can I ask a quick question?
You may.
If you don't have a, what do you call that thing, a thing at the back? That stops
The riving knife.
Riving knife.
Yes.
If you don't have, I've got a homemade table saw.
Okay.
I don't have riving knives or anything like that. Is it possible to say that because you're pedantic and because you're constantly mindful, you can mitigate any form of kickback if you're paying attention? Or is that like a fool's paradise kind of like?
Fool's paradise kind of like, yeah. The problem is if you listen to anybody who says anything about an accident that had happened on a table saw, is I wasn't thinking and I was reaching behind, or I wasn't concentrating, all this. And us being human, there's always that risk. So, and I'm not saying set it up well and have a riving knife so that you don't need to pay attention, but that allows you just to a certain extent mitigate the risk. And remember, as mindful as you are, you may have a piece of lumber that's been case hardened. Okay, so typically South Africa's pine that's been dried too quickly. So it's get dried too quickly, then you have harder sections, or you're cutting through a knot. Okay, and then the wood flexes. And it doesn't need to flex much. So it doesn't matter how much attention you pay. It flexes, it pinches, it catches, it comes at you. For your, just in your case, is, no. Who makes the yellow push blocks? Not Miles Craft, the other one. Microjig. Microjigs actually make splitters that you can put in behind your blade in your, if you've got a zero clearance fence, so you can put that in, you just drill 2 holes, and you get different sizes, and that actually is a splitter, which is a nice aftermarket solution, so have a look at that. Yeah.
All your measurements make me feel good, because like I'm constantly measuring them, but it sounds like you guys do the same with your fancy stuff, so.
Yeah. So, okay, so adjustment is really, really easy. Get yourself a set of Allen keys. Also get your sets of Allen keys that are both imperial and metric, because I can guarantee you some table saws are imperial. Okay, so this side is closer to the blade than this side, so I want to move it that way. I've got 2 options. We need to check that as well. So I need to move that away. So you'll notice that this has got pads. The pads ride on the inside here. And that will either push your fence away or closer to the blade. So what you do is, there's an Allen key there, and there's an Allen key there. And that just flexes. You see that table, that tab there? It flexes in one way or the other. Okay. So in this particular case, I don't want to spend too much time on the settings themselves. You know it's going to be a good day when the first Allen key you pick up is the right one. No, that's actually not. I think that might be metric though. Yeah, it's metric. Okay. So I want to move it away like that. So I can extend that pad. Let's see what happens. And it doesn't need to be adjusted much. Huh? Okay, we're going to do 1 or 2. It's better already by about half. So by going back and forth, you can then adjust it. It's really not a difficult setting to adjust, and you need to have a look at your own table saw and see how it is adjusted. The contractor saws, the Bosches and the Volts and so forth, are notoriously hard in some cases to do for some. But that would be then how you do your fence. So we've got the blade parallel. Because we set the fence parallel to the miter gauge, you then can assume that you're parallel to the blade. And then if you're going to have it offset in any way, have the back of the fence away from the blade slightly rather than closer to. Okay. But never as this one is at the moment. Okay. So next would be we'll do miter gauge last because that's probably the least important. Now, we come to where we discussed at the beginning the importance of a engineering square. So I've got a couple of squares here. This one I got from Hardware Center here. So that one's not too bad. This is a in-size. You can get them from tooling shops and you can order them. This is an accurate one. And then this one is from our friends down the road. And this one is the one that I use to do all my settings. So I use this to set up all my tools. I always keep it oiled so that it doesn't rust or anything like that, and I keep it in the box. So I want to check that my fence is square to my top. Now, it's only really very important if you use your fence with a thin cut and you need the other side to be exactly parallel or 90 degrees. But if you're doing a rip cut and you only need a certain length, yeah, as long as your reference edge runs and your measurement is accurate, it can be slightly offset. And mine, actually my table, so I can adjust it to a certain point and no further. So I'm maybe half a degree off, but it doesn't affect the accuracy of my rip cuts because I still have my reference face riding. But ideally, you should get it as perfect as you possibly can. So tighten it down because that's the format in which you're going to use it. I always have a light source in the back. And you can see there, I'm tilting away from, so I'm off by a little bit. And the way that you adjust it are these. So very important that we use the correct Allen key size because we don't want to strip those. Those are little plastic ones. Ooh. Tough day at the office. No, that's the wrong one again. There we go. So, in effect, what I want to do is I want to move my fence over that way. So, don't adjust it while it's tightened. Loosen it because you're putting down pressure and you will strip this. And really, very little. And just keep going at it. I do exactly what I told you not to do.
You might need to drop the other side.
Yeah, we may. There we had a lot of movement. Now what you may notice on this particular fence is that, okay, so what do I want to do? The blade of your square is touching the top, it's touching the bottom, and there's a very slight gap between those, and that means that your fence, when it's manufactured, it's flexing and it's a little bit hollow. And when it comes to aluminium fences, that's sort of par for the course. That's something you need to live with. But then again, we can see 1/1000th of an inch light coming through. That's the minimum. And if you look there, that's really not a lot. Okay? Always, let me do this. and you should see a slight gap. Always have a light source in the back, it just makes it easier. Okay, now often what will happen is, especially when the cheaper or the older table saws, is you may have it square there, but not square there, and that means your whole fence is twisted. And there's very little you can do about that. But it does happen. Okay. That's the fence. Any questions? It sort of feels like I'm rushing through, and I don't want to leave anybody behind. So if you have any questions, please feel free to ask.
This gauge, does it come with the table saws when you buy it, or do you have to buy it?
Yeah. You weren't here, so I do have a solution other than that. So I got that fence, and I've got the magnetic base and the dial indicator, and I built my own. Okay, but it's really important that you have something that sits in the mitre slot and keeps it straight as you push it along. But yeah, you can do that as well. So that is another option. Didn't expect it to fit their table saw there. So that's tabletop. That's the macro adjustment, and then we're focusing in, as I mentioned earlier. So we've done blade parallel to mitre slot, fence parallel to mitre slot. Then we focus on the fence, that it is square to the tabletop, front to back, and then square this way. The other really important setting is the blade square to the top itself. And once again, this is where you need to get to know your tools, because if I set my blade square, if I'm standing at my table saw, if I set the fence, my blade square on this side of the blade, it's square. I get a square cut. But if I move my square to the other side, I'm out. And if I set it square to there, I'm always out. So don't ask me how, but that's the case. So this is how you get to know your tables and your equipment. So effectively, it should be square either way. It doesn't matter from which side you check it. So there's sort of a quick and easy solution that the guys have come up with, and they say it's accurate enough, but I found that it's not as accurate, and I don't particularly like using it, and that is your electronic angle finders. These guys. I find that I'm not getting, it's good enough for certain things. So if I'm setting up my pillar drill or something like that, it's fine. But I find on my blades that this isn't. Could just be my example, but I don't particularly like it. It's got a magnetic base. You put it down, you zero it. Okay, that's zero. You wait for it to settle. Oftentimes when you have movement, you need to settle down. So that is my zero, and now I should be 90 degrees to the top, which it says I'm not. You guys have a look there. Okay, so let's do, which side is zero? So you zero it, is it zero? Yeah, the moment you turn it around, it's no longer zero. Yeah, but I'm referencing on the top, so it's still not giving me a zero. And then I move it there. What? Yeah, okay, so it's the same both ways around.
But you've also got that problem.
Yeah. Put it down zero, step away, have a cup of coffee, and come back in 15 minutes. So this should be able to give you 90 and... Why does this not turn? So you can go from there, and you can set your angles and so forth. And I find it to be a little bit fiddly. Now, it's really difficult to get an accurate and a decent-sized 45-degree engineering square. Well, you can't really call it a square. What do you call it? Okay, so, but you can set 45 and from there. But most of my cuts is 90 degrees to the table. So your setting system on your table saw has got a hard stop often, and then they set it up so that it stops at 90 degrees, it stops at 45 degrees. Don't trust that, because once again, you are dependent on a manufacturing accuracy, which is something you can't really depend on. So use set squares and so forth when you're setting up your tools.
Can you use the block of the
You can. Of a combo square, yes, you can. Yeah. So what I like to do is I like to use my square, and I like the fact that I have a big square, because here I need to hang on to the square itself, and because it's light, it may drop in there, and I don't have a lot of on the stock. So I like to have the big square because I can just set it here, leave it, and then I have my other hand free to do my other settings. So, and then your light source. Okay, and you may notice, and do be careful where you position your square against the blade, that you're not hitting a tooth. Sometimes you'll see the manufacturing, it's not all perfectly flat or flush. So have a look at where you're putting it and just position it in the right place. But there, okay, so I'm a little bit over this side, which is sort of confirmed by this, by the way. So what I do is I get on my knees, adjust where I want it, and you can see there's light coming through once again, and that's because of the manufacturing of the blade. Okay, so that's a little over, and this I do regularly, and I do it every time I change a blade. Your question earlier. So I set that 0. Let's see how accurate we are. Still 89. So I moved it. I moved the blade, and we're still at 89.9. So I'd find the electronic meter not to be as precise and as fine in its readings as I would prefer.
It's like 0.2 degrees accurate, and that could be either way. So
That's the claim. Yeah. Also, and this is something that's chased me around, do be careful that there isn't any dust here or on your blade. Okay, it can keep you busy.
and the magnetic filings, because we've got a magnetic base that attracts a lot of filings, I find that problem.
Okay. Luckily, I don't do metal work, so I don't struggle with filings. Yeah. Yeah. Okay. Yeah. So now we square on this side. Let's see. Maybe we've got the same problem here. Yeah, and we're not square. Same problem. So you sort of need to find on which side you do your measurements on your blade to get it square. Okay, so that now is square. I've hit the hard stop on, that's too far. Okay, this is where more than one hand would work. Okay, so that is now square. And now let's have a look, see where we are. $90. Okay, so once again, just like my table saw, I get a more accurate measurement if I'm on the right of my blade than on my left.
On the blade, you turn it all the way up to measure it, but on mine, when I turn it up and down, the blade actually seems to do a little bit of a winnowing in that process. So the angle is changed by, 0.2 degrees
Yeah.
in the actual adjusting of it up and down.
So that could either be the worm screw that's warped. So your in-feed and out-feed worm screw, and that could cause the wobble. And it could also be the sliders that your system sits on. And there's very little you can do about that.
But I mean, that 0.1 degree, is it going to be significant?
Depending, once again, on the size of your project. So if you're doing very small projects, it amplifies any inaccuracy that you have on your equipment. So, but at some point, there's a point of diminishing returns. So I mentioned earlier, it's not precision engineering. So there's a certain point where a 1/4 of a millimeter no longer makes any. Yeah, or clamping pressure. It's like I follow a lot of guys on the internet, and one of my favorite guys is the English woodworker. I always forget his first name. But he did a video where he sets up a plane and shows you how to do the chip break and what have you. And he's an English guy. He's got a very cool sense of humor. He says, I stopped measuring everything smaller than 1/16th of an inch. Doesn't really matter. So it's really up to you and how precise you would be. Look, and you can be chasing your tail with setups. You really, really can. And effectively, once you've built something, you realize it wasn't necessary. So, yeah. But I check this every time I change a blade, or every time I set my blade away from vertical. And I also, I've done it now automatically, started doing it automatically. Every so often when I make cuts and I build a project, I will just pick up my square and just check that I'm still square. Maybe that's a holdover from my previous table saw that was constantly giving me problems. At least I used to check every single piece that came off a table saw. Up, check it, and I just find that it's taken too much time. Say again? Yeah. So I do that every time I change my blade. And then, of course, that's probably of all these is the one you're going to need to measure the most. Because once you've set your tabletop, set and forget. Once you've got it parallel to the mitre slot, it should be consistent. If you have that parallel to your blade, your fence parallel to your blade, and your fence square, it's probably set and forget. As I mentioned, I do all of that once a year. I go through everything and I do it. Okay, it's just good practice to have it do it like that. But apart from that, setting this square, the fence square to the top isn't all that hard. Setting it parallel to the blade isn't all that hard. And then the hardest one of them all to do is a mitre fence. And it's directly proportional to the quality of your mitre fence. And a mitre fence can cost a lot of money. So this is the mitre fence. Now, usually the mitre fences that come with table saws are really bad. That cannot be considered accurate in any way. You've even got movement front to left. So it depends on how much pressure you put there or on the other side. Okay. So mitre fences or mitre gauges in the mitre fence, often they will come with little screws and washers that you can tighten just to get them to sit tight within the slot. This one you may notice does not have that. So you have that movement there. So what you can do is you take a punch, metal punch, and you hit here in areas around the fence. What that does is it mushrooms the metal out of the punch, and it causes it to sit tighter inside the slot. I've tried that once on one mitre gauge. It didn't work, but theoretically they say it could. So if I'm going to buy a table saw, generally what I would do is my first purchase after that would be a dedicated mitre gauge, or just make yourself a crosscut sled and live with it. Yeah. Don't agree with that statement, by the way. Yeah. The crosscut set is only really advantageous in the fact that it's got a bigger capacity, because there my workpiece goes in and I've got that much space to the blade, whereas with a crosscut sled you've got more capacity, but my crosscut sled, my fence sits on the back, not the front, so I've got even more capacity than a standard one. I don't have to worry about what that distance is. So upgrade this. This is going to keep you busy. Incra fences are really good if you can find one. They used to bring them in. They're not that common anymore. Really expensive. And then there's a couple on Banggood that's really, really good. And there's one on Banggood that you've got hard stops on every degree. I don't know if you guys ever watched a guy called Hooked on Wood. He's a Dutch gentleman, and he does a lot of reviews on the Banggood stuff, and he's got one of those fences, and that's really, you get nice extensions and stuff. That's really nice. But adjusting this is you're going to need this, and in spite of what I told you, you always use the same datum. You need to move over to your other slot to be able to do this. Drop your blade. And I used to adjust, measure, do cuts in between, and it kept me busy long time. So what I found, I saw on the net, and I can't recall who actually showed you how to do this, is you use your fence, or sorry, your mitre gauge. So you find a way to attach your mitre gauge to your square. So you just use a clamp or something to keep them together. And now you can drop, I don't know how you can drop, this can actually adjust. Yeah, this one's actually got a pivot, so you can adjust it down. So you adjust it down so that you hit this, your blade of your square. And that actually gives you the capability to do the same and do a more accurate adjustment. And do remember that if you set your mitre gauge and you cut a piece of wood that's only that wide, this wide, and you measure it and it's square, and now you cross-cut a much wider piece and you measure it again and it isn't, it's because it's out so little that you need more distance. You need to multiply the fault or the misadjustment to be able to see what's going on. And that's what's nice about a long-bladed square, is I can have that distance there, and I'm hardly ever going to cut a piece of wood or cross-cut a piece of wood in the kind of work that I do that's much longer than that, and that just gives you a more accurate. So you move that up and you attach it to this one. I don't even want to try it with this one because it doesn't matter what we're going to do, it's not going to be in.
I'm not following why you're checking the two fences.
What do you mean?
I'm not following what the purposes of that exercise.
So instead of adjusting, so what I can do is often you would use a square on your mitre gauge against the blade, the face of your blade. And then you do your adjustment. Then you cut a workpiece and you measure it and check it to see if it's square. That's typically what you would do. Why I like this system is I attach this to my mitre square and I run my gauge along the blade of my set square. And then I do my adjustments on that. So I don't have to take it off, do a test cut, come back, measure, adjust, come back, measure, adjust every time. I can just use my measuring equipment and check my distance from here and here in relation to one another and do the necessary adjustments and then do a check. Yeah, let me show you. So let's say that's there. That's against the blade there. I'm just going to hold it. So you do the same exercise. So that should be set to 0. Okay, because I'm holding it. So that you set to 0. And then you move it down. And it goes in and out. Your measurement here changes according to if you are square in relation to your gauge or not. Do you get it? Ask now if you ever hold your piece. What don't you get?
I'm not sure. If we've already done the setup the way you've explained earlier, what's the purpose of this thing?
It's to get the
Mitre gauge needs to be square to your blade.
Oh, so you want to make sure the mitre gauge is not sitting screw in the track.
No, it's got nothing to do with the track. Remember, for you to be able to get a square crosscut, the mitre gauge needs to be square with your blade.
I was assuming that the mitre gauge is a 90-degree setting in it. Like,
Don't trust it. Don't trust it, ever.
because the one I've got literally like clicks into place.
Don't even trust it then. You'll see that you can remove your fence or loosen your fence in the front to actually do micro adjustments. Okay? So even if it's got a hard stop here, don't even trust that. Don't even trust an Incra gauge. Okay, mine was out of square, out of the box.
Sorry, it took me
No, it's not a problem. That's why we're here, and that's why you should ask your questions. No, don't trust the hard stops in any one of your tools. Okay. There's somebody who did a test on a Harvey square, which is supposed to be one of the better ones, and even the one that he had out of the box was out of square. So don't trust them. Okay. Yeah.
that thing with the so like the mitre gauge, I got what do you call that thing? Mitre sled, whatever.
So this is the mitre gauge.
Yeah, so that one that I got in the as part of my table saw.
Yeah.
I'm using it with the jig. It cuts, small hammers. I'm like shaving them down, piano hammers. And we're literally trying to work to 0.2 mil the accuracy, or at least it's 0.2 mil possible because that thing actually moves around a lot. So ended up putting tape around it so that it's in the set, but it keeps on wearing out.
So in your case, you would actually be better off making a dedicated crosscut sled set to those particular angles, because that will give you much more consistency.
The jig is consistent and works well. The jig that's supposed to go onto the or in front of the set. But I'm thinking maybe I should just get a better rail that fits properly into the.
Look, it's always a good idea to get a better miter gauge than the one that you got with your table saw. However, in your case, okay, so build a crosscut sled, dedicated crosscut sled, where you make your own bar that sits in the miter slot with the specific angles, and you're always going to get the same results. Because the more components that is adjustable, or that are adjustable, that you add to a system, the more single or very small mistakes compound, resulting in bigger mistakes. So the less movement or movable parts you have in a system that you need to adjust, the more accurate and consistent your work will become.
And notice this tabletop is steel.
This one? No, this is cast iron.
So that blue Bosch one is aluminium or something shitty.
It's usually aluminium, yeah.
You know, and so even the track inside is not like machined well. It's not machined. It's like folded or whatever.
Once again, you get.
So when you know, when you push, it doesn't matter how perfect the thing is that you push through there. At some point, it will start getting stuck.
Get what you pay for.
That's why a fixed sled works nicely because it's running on both miter rails.
Yeah. And remember, even though to some extent your aluminium top flexes, as long as your slots remain parallel to one another or somewhat parallel to one another, you will get a better accurate result.
I'm worried I've damaged the table already just by putting some wood down too hard.
Yeah. No, I wouldn't be able to work on them. Yeah. It's likely. Jordan, have we got time for a break, or can we pause for a break? Okay. So that's the table saw. Any questions? Then we take a break, we come back, and we go through that one there. Any questions we can discuss? You can do. How many people have we got online? Okay. Questions? Anybody? Okay. For the guys who have come late, just a quick introduction. My name's Dylan. I'm a furniture manufacturer. I design and make furniture. I'm moving my business much more into woodworking education. I've got online plans and stuff. If you'd like to receive my newsletter, you also get free plan sets. If you do, I've got push blocks and crosscut sleds and stuff that you can get free. Sign up, I'll load you onto the system, and then on the next newsletter you'll be able to get access to all of that. Okay. Great. So let's have a quick break. If there aren't any questions, I'm going to sort myself out, and then we move over to that one there, to the bandsaw. That one's a bit of a dark art. So, yeah.
This made me feel so much better about all my measurements. Thank you. I thought it was because I made my own table, but I'm like, oh, I must just buy a real one.
Yeah.
No, I don't know.
Of,
Throat plate.
I'm not exactly sure. Okay, we can take it out.
I've got a jet, and I took out and I've used MDF.
I do it with all mine as well, because that gives you, I've actually got blanks pre-cut, and as I trash my blanks, I just put a new one on and cut through it, yeah.
Reason? Because you've got a narrower slot.
A narrow slot,
You don't get bits falling down.
that's so it's safety, yes, and it's also a cleaner cut. So they call it a zero clearance insert.
You've got more support on the other side.
Exactly, you get less breakup.
Yeah, but how thick do you make an MDF? As deep as it will go into this?
Yes.
It has to be flush with the tabletop though, no?
Yeah, and then, but then when you see, once again, that Bosch one, I'm actually really disappointed with it because there were so many small things that bug me. As I take it out the box, this thing is sitting proud. So when you push a piece of woodwork,
And you don't have any grope screws to adjust.
no screws, nothing. It's like a fresh piece of aluminium.
Okay.
But you know, it's like very flimsy. And if you, as the wood hits this, the wood tilts. I mean, a little bit, but enough to.
Jordan, can I switch off the mic? Yeah, just preserve the battery. Are we looking? the caveat that if you set to a slower speed, you can cut soft metals on certain bandsaws. So the Metaba one that stands, the BS something, can't remember, that actually has an adjustable speed, so you can do soft metals as well. So you can do aluminiums, brass, and that kind of stuff. But that would be the only reason that variable speed would be of any use.
Really, irrespective of feed speed and hardness of steel.
No, there's no point whatsoever. Sharpness of your blades is much more important than the speed. So it's not like a router, because remember it's the same size blade. So your speed of that your tooth travels isn't changing as a result of the diameter of your blade. So in that sense, you wouldn't need it like you would do on a router, because a router, your bigger bits, because your rotational speed on the outside of that radius is much faster than on the inside, that would then be determined to a certain extent by the speed of your motor. And so turning tools, yes, here and there, no. Would be no point. Are we back on sound as well? Okay. Cool. Let's go over to the bandsaw. Now, this is not as probably as precise an adjustment system as you would have with the table saw. And once again, it's because of its use. You're never going to get as an accurate cut on a bandsaw as you're going to have on your table saw. And remember, your bandsaw is more often than not for processing stock, raw lumber. It's a safer option to process your raw lumber on a bandsaw than it is.
Roughing out.
Yeah, roughing out. Really, when accuracy becomes really, really important is when you're doing veneers and that kind of stuff, or making boxes, bandsaw boxes and so forth. Although, when you have a really good blade and it's set up relatively well, you'd be surprised at how accurate you'll be able to get this particular tool. My tool, sometimes my bandsaw is, I get a more square cut than I can get on my table saw sometimes. So it really depends on how you set up. It's a bit of a dark art, and it's a bit fiddly, but once you get the gist of it, you can do it relatively easily, but there's a few things that you need to keep in mind when you start looking at your bandsaw setup. Now, when I change a blade, so you can set it up so you don't have a lot of changes which you need to do with the blade, but it's also dependent on the bandsaw itself. So, and one of the main reasons for that is the blade position on your flywheel. Because this is relatively important when you set up your blade. So on your wheel, top and bottom, more often than not, on a bandsaw, so if you look at the wheel, edge on, so let's say that's your wheel, okay? Then you've got what they call a tire or a boot. That is your rubber that runs around the circumference. Sometimes, well, more often than not, it's got a crown, okay? And that's related to the tracking of the blade as it goes through. And it's the position of where your blade is in relation to that crown that is a big part of your setup. So a lot of guys, are we in your way? Okay, so a lot of your adjustments is related to where your blade sits in relation to that particular crown. My bandsaw is lacquer because I'm flat, my boot is flat, so I can put that blade wherever I like. So if it's a thin or if it's a narrow or a wider blade, I can set it up that my blade position, let's say the back of my blade is always in the same place, and that helps me to be able to adjust this a little bit easier than I otherwise would have. But most flywheels have that particular crown on, and also this is also, and if you talk to guys who are heavy users of bandsaw blades, mention the word drift, okay? And you will have a discussion. It's like the Toyota Land Rover discussion, or the BMW KTM discussion. Okay, it really keeps a lot of guys. Some guys swear that drift is a fact of life, and other guys say if your bandsaw drifts, your setup is wrong. One of the guys who typically will say or have that discussion and say that you should not be getting drift is a guy called Alex Snodgrass. So if you go and Google him, he's got really good videos on setup and where you need to set your blade in relation to where the crown sits. Snodgrass. Yes. S-N-O-D grass. Okay, really cool guy. And apparently, if you think bandsaw boxes are cool, apparently he cuts a takbok. What's a takbok in English? A moose or something like that with the horns. He cuts that out of a single piece of wood on a bandsaw. And he does this cut, he does that cut, and it's a solid block, and then pieces just come apart, and then you've got a moose on the inside of this block. Apparently, it's really cool to see. That's one of his party tricks, apparently. Okay, so blade goes in. So as a start, when you set the bandsaw, all your adjustments needs to be loosened and away from your blade. Okay, and the main reason is I've negated to actually do that in times. I put a new blade on, then I'm adjusting here, and I realize that I didn't move the bottom guide rails out of the way, and that's been pushing it forward, and the moment I do it, my whole setting on top changes. So that's a pain in the rear end. So whenever I change a blade or anything like that, I make sure I move everything out of the way. This one's got two separate doors. Mine opens up as a single door. So open that up. Okay, so that opens up. So that's the top rail. What's nice about the Laguna ones is for me to be able to set, and most other bandsaws, is you need to get into the bottom area here to be able to get to where you do your settings. What's nice about this one is the settings are outside, so you don't need to open the covers to be able to change your settings. Okay, which is completely loose. When's the last time you guys used this? During the demo, eh? Yeah. Okay. So it's completely loose. Okay, so that's moved out of the way. This one's got a little dust cover that I'm going to pop down there because that can stop us from working here. Now, in effect, you would never need to adjust, okay, the angle of the wheels. That is just or preset in the factory. And it relates to the, and I've seen a lot of videos where you put a straight edge flush, and it has to be flush to the top, and it has to be flush to the bottom. And actually, they set the bottom wheel offset slightly to improve the tracking on the top wheel. So if you can avoid it, don't adjust the wheels, or have a qualified technician actually do those particular adjustments. And you do it by offset screws in the back, and you've got 4 screws, and you tighten, you loosen, you tighten, and it's really tricky to set up. So in effect, it should be standard and set up correctly from the beginning. First of all that we do is you need to check the tension on the blade, because if you don't have the tension on the blade correctly, it doesn't run straight between the two wheels, and then there's no point in doing any other adjustment. Okay, so check the tracking on the blade. You've got the little windows that show you where the blade tracks, but if this gets full of dust and stuff, it's difficult to see. But you can have a look, turn, be careful that you don't put your hands, it's an open blade. Also, don't push all the way there, because that flywheel's got, it will break your fingers. I've been caught like that once or twice before, so I'm quite careful of that. But turn it by hand and see where it tracks. But before we do that, we need to check the tension. Now, often a lot of guys will trust on the gauge that's inside the machine, and some of the older machines don't have that. They don't have the gauge. Don't trust on the gauge. Now, something I neglect to show people is you need to tension the blade. So most bandsaws will have a tensioning system, because when you don't use it, you release the tensioning system, because your bandsaw blades can stretch. And that's why you release the tension on the system. My particular bandsaw doesn't have that. So every time I untension it, I have to do it on my tensioning wheel, which also means that every time that I work on my bandsaw, and I haven't been working on it for a while, I need to be sure that I tension it, because I don't want to switch on the bandsaw while my blade is untensioned. There's a certain employee in this particular shop that you can ask what happens if that happens. Okay? So because you have the blade climbs off and it will break, and these, if you have if you've got bearings as your guides, it can damage a bearing, and a bearing is easy to replace. My particular bandsaw, just to replace a set, is almost 10% of the price of the bandsaw to replace the, what's it called? The tracking guide, but the material it's made of. Not Teflon? Say again? No. What's it? Turn the machine slightly. Let's close up before we break a door off. What we can do is we can turn it all the way towards you. Is that okay? Okay, let's go. How's that? Okay. Ceramic blocks. Because I'm thinking space shuttle, and I'm thinking ceramic knives, because they use the ceramic tiles on the outside. Okay. So replacing ceramics is not cheap. The Lagunas are relatively cost effective. Mine are horrendous, and I've actually chipped mine. I'm coping without having to replace it because it's simply too much money. So what I want is first of all the tension. So a lot of people will trust the gauge. Don't trust the gauge. Now you'll see that it actually shows you the thickness of the blade, or the width of the blade. Now that's from the front of the tooth to the back of the blade. So that will be your total width of the blade. Okay, so there's the back of your blade, there's the tooth, so it's that distance there. Doesn't need to be all that accurate, but just for clarity's sake. Now this one, I think, is about 10 mil, maybe 12. So if you look there, it's set to 10. I would probably be leaning towards 13. So if you don't have this little dial gauge that tells you what your tension is, how do you know what your tension should be when you set it? So ideally what you do is you put light pressure, just finger pressure, and it shouldn't flex more than about 5 millimeters when you do. So if I press there, I'd say that's a little bit more than 5 mil. Just light pressure with the finger. You don't push it all the way back.
You can press anywhere. I mean, here as well.
That was the next term I was going to say. Don't do there, because you might have it set between the guides, which means it's not going to move anyway. So go away from the guides when you press. So about 5 mil. Not all that happy with that tension, so I'm going to tighten it up. Of course, you can't see from the side. Yeah, so I'm happy with that. Try it. Just see, press so you see 5 mil, and you can feel how much pressure you need. Don't need a lot of pressure, so slight pressure. Okay, move about 5 mils. Now I'm happy with the tension. Now I can look at the tracking of the blade back and forth. Now, the manufacturer will tell you that the blade needs to be in the middle of your boot and your guide. So do keep in mind that the middle of the blade is different for different widths of blade. So, and your teeth aggressiveness. But ideally you want to be here in this area on top of the crown, here. However, you can imagine that the wider your blade is, your teeth then, or the teeth on the blade moves further away from being supported. It starts hanging in the air, and that's where your blade starts drifting. You want to provide as much support for the teeth as you possibly can. So in this particular case, I won't necessarily have the blade running exactly with the middle of the blade on the apex of the crown. That's the correct term, I think. On the apex of the crown. I may want to move it a little bit further in or a little bit further out so I can provide support to the tooth. So I want my teeth to be here, and then however long the blade is or how wide the blade is, sort of hang it off the back. But do keep in mind that the wider the blade becomes, the more you risk hanging it off the back. So you need to sort of look at it and balance it as well.
So you can fit different width blades to a single machine?
Not at the same time.
Not at the same time.
Yes, you can. So this one goes, I think, up to 25 mil or an inch, which is then nice. Different blades. It's the same with a table saw. Table saw, you have a general purpose blade. You have a ripping blade. You've got a crosscut blade. It's the same with these. You've got narrow blades with a lot of teeth that's for fine curves, so you can turn the corner. You get rougher teeth or fewer teeth per mil or per inch. That gives you a rougher cut. You then have very wide blades that you can use for resawing, because the blade is very wide. It stays straight in the cut, which gives you an more accurate resaw. Because remember, this blade, even here, you can flex it. And even if you have it inside or in between the guides, it can still flex somewhat, because your guides don't run right against the metal, because you either wear the blade or you wear your guides. The ceramic guides you can, but with your bearings you don't, because the bearings turn and they heat up, and you can lose. They can either seize up, or you can lose. They can get so hot that you can actually lose the set in your blade, because this is a spring steel. The moment you heat it up, it wants to recover and go back, and then you don't have any more set in your teeth. So that is your position of your blade in relation to the crown is really, really important, and that is what limits the risk of drift as you are in the cut, because you want to support the teeth. So rather than have the middle of the blade on the apex of the crown, rather move it back so that the teeth are just in front of the crown, and that provides support for the teeth. Now, this is a consideration when there's a crown on the flywheel. In the case of my particular bandsaw, it being flat, I can put the blade wherever I like. Doesn't matter. I always have the support.
Does that not damage the offset of the teeth? Because the teeth are
It's a rubber.
offset.
Yeah, it's a rubber. It won't put it back. So it's rubber. It won't. So that's the next thing you do. So how do you adjust its tracking? You have an adjustment screw in the back that either push the wheel forward and back, and that will change it. So you can see there, now it moves forward. The blades now move forward. Do be careful that you don't adjust that far forward that it climbs off. That can happen. So I'm going to go the other direction and bring it back. Watch my fingers. And very small turns. We're talking a fraction of a quarter of a turn. Okay? That's where I want to be. And once you've adjusted that, more often than not, it's got a locking nut. And that stops any further movement. Okay. And that's it. That's where we want to track. Now remember, where it sits on the flywheel determines how far your guides go forward and back. Because the further back you bring your blade, the further back your guides need to be. The further forward your guides need to be. So set it, and then you start working on your guides, and that's why I have my guides moved, so that the guides don't affect where I am on my wheel in any way inadvertently. Next part is really your choice. Do you do the bottom first and then the top, or the top first and then the bottom? Really, it's up to you. So I like to do the top and then go down to the bottom. So first of all, the side guides. I set the side guides before I do the back. So on the sides, technical term is the guides, and I think the back is called the thrust. And it's called the thrust bearing because traditionally the guides on these are bearings. They used to be metal. You had metal pins, and you still had, it's a carbon steel pin, and the pin does the guiding. Then they went over to bearings, and then some people still swear by the bearings. Bearings are good, but generally now you'll find that they use, I've forgotten what it is again. Ceramic, yeah, the ceramic guides. What's nice about the ceramic guides is they can run against the blade without overheating because the ceramic don't overheat. Dissipates the heat. Whereas on bearings, it runs the bearings heat up, and they can either cease, or as I said, it heats up the blade and removes the set on the blade. Although you can run the blade next to the guides if you've got ceramics, I don't. If I want to do a very accurate cut, or I do a resaw and I want that blade to stay straight and not twist in the cut at all, I may sometimes position it against, but sometimes it's also relation to how well the blade is made, because the blade is a band, two ends get brought together and they get welded. So there's often a rough area where the weld has taken place, and that will hit my guides. So it makes either a disconcerting noise, or I'm afraid that I need to fork out 6,500 rand for new guides. So I'm a little bit finicky with that, but unless I need to do very accurate cut, I offset my guides. If you have bearings, you want to offset them slightly because you don't want the bearing to constantly be running because they can overheat. So it's just a guide so that, let's say we're looking at the guides from the top. Okay, and the blade runs through here. You don't want it to twist in the cut. So you don't want this to happen. You want it to stay in the cut as straight as you possibly can. Now that's another reason why this you can adjust up or down, because you need to be closer to your cut for more control. So there's no point in having it up here and cutting 6mm plywood, because you're then going to get that twist. It doesn't matter where you put your guides in. So that's the reason why you have that up and down movement. On some of the older or even cheaper bandsaws, when you adjust the guide system up or down, it also adjusts the settings, because this system here isn't straight, which means you need to tweak your settings depending on where it would be. And then I don't want to go back and do the settings, and then I become lazy, and then I have it up, and then I cut this, and then I get frustrated. So it's really depending on what you are using. So now we're happy with where the blade is, front to back. We're happy with the tension. Now we go to the guide. So you'll notice that on this particular bandsaw, this is really, really easy to set. It's really easy. It's one of the easiest or easier ones that I like to set. So how far forward? You want the front of your guide block to be about 1 millimeter behind the gullet of your tooth, between the two teeth. So if you have the two teeth here, so let's say that's a tooth there, that's a tooth there, that's your gullet. You want to be about 1 mil behind the gullet. Okay? You don't want to be in front of the gullet, because then you start hitting your teeth and you start screwing up your set. If you've got the ceramic guide blocks, it's going to chip your ceramic guide blocks. So be careful of that. You want to be behind the gullet, but also not so far behind that the front of your blade starts running all around in your cut. So I want to be, okay, about 1 mil behind, and then I can tighten it, because that's my front to back movement. Now you may have noticed that on this particular bandsaw, you can do this. So another thing you need to keep in mind is, as your blade runs, so that's viewing from the top. Now viewing from the front, you've got your two guides and your blade running through there. You don't want your guides to be sitting like this. Now you're hitting only the bottom of the guide here and the top of the guide there. It should be parallel to your blade. And the easiest way on this is not to eyeball it. Loosen the two guide and pinch the blade. Just lightly pinch the blade. Okay? I'm not worried about front to back now. I'm just making sure that my course setting left to right is set. Okay? So now I'm parallel to the blade. So now I know I'm going to hit the top of the guide and the bottom of the, well, not the top of the guide, the top guide and the bottom guide. Now I'm happy with the vertical adjustment. Now I tighten that. Okay? So now I know, you'll notice that I'm top to bottom parallel with the blade, or I should be ballpark. Should be close. Okay? Now with this particular one, because you've only got one set screw, I should have actually paid attention to front and back as well. Okay. But I am about 1 millimeter front to back. When I loosen this adjustment, I also have slight adjustment there. Vertical as well. But take as many variables out of the system as you can. So my distance front to back and up and down, so vertical and horizontal, I'm now happy with. And I'm about 1 mil, give or take, behind the gullet. Have a look at it. See what it looks like. And it needs to be for both sides. Happy so far? So what I can do, let's say I want to set my blade so that it actually touches the guide blocks. I can actually now turn my blade and make sure that it moves freely. It doesn't. See there? Doesn't. So which means I've put too much pressure on the sides. And this is a common suggestion in the user manuals, that you do this when you set ceramic blades, because then you know it's parallel to the blade. But if you put too much pressure here, you pinch the blade, which defeats the object. So what I like to do is I like to run my blocks slightly away from the blade, but very close to. And the only way I can really do that is have a look at it from the front and then really do eyeball it. Or even put it slightly, just so that it touches the blade. Now the pain is, the moment you tighten the thumb screw, it sometimes twists the block. So do keep attention. Watch both the top and the bottom guide, that it stays parallel in this direction.
Will it not help you to put a piece of pipe in between?
It could, yes.
Or feeler gauge?
Yeah. You could do a feeler gauge as well. Yeah, you can do either or. Yeah, the paper trick's quite handy because you can do that with gearing as well. That's the old trick with gearing. But yes, you can do that. However, if you want your guide blocks to actually ride on the blade, you can't do that, and you would need to put very light pressure. So I've offset the one side. Offset the other side. I'm quite close and I'm running freely. Okay. Now I do the thrust bearing, because this has also got to do with drift. So when you do a cut, you push the wood into the blade. Front to back, this blade flexes quite a bit. And the thinner it is, the more it flexes. So what you want to do is you want the back of the blade to hit the bearing. Okay? Bearing or guide. And what that does is it stops the flexing as well. So this is also important for drift. So the best way to do this is, just get my head around this one. Okay, so that's that adjustment. Okay, seems like I've made a mistake. As long as your guides are vertically aligned, okay, so they're perfectly parallel with one another in a vertical sense, this setment screw here will actually allow me to twist them around. And this is where I can show you what you should be looking for, but your bandsaw may work very differently than this. Mine sets each one differently or separately. So it's really a case of knowing what to look for and then applying what you've seen here to your own particular machine. Okay? And that's why bandsaws are such a dark art to set them correctly. But once you get it, it's really, really easy to do. So we have that. So this one here will do both. So I do need to be careful. So how far forward and back does it need to go? So I like to set it slightly forward. When I tap it, you can hear it hitting the thrust bearing. So it's not against the thrust bearing, but there's a little bit of a gap. So how hard do you hit it? So Alex suggests that if you hit it with the back of your hand, without the teeth hurting you, that should be enough. Okay? But if you've got a blunt saw blade, you might hit it harder. And I'm always testing by turning the wheel just to make sure that I don't pinch anything and having a look at it. That's quite close. So you can see here, there's quite a bit of movement there, even though I'm close. But if I bring the wheel or the system down, that little bit of flex is going to have less than an effect there if I had it up top. And that's the reason you bring it down. Okay, then we go through the same process at the bottom. And this is where the light isn't always okay. So this one's got two adjustment screws in the back for front and back. This was completely loose. So that will give you front and back. I just want to check something. Yeah, so that's forward and back, left and right. With your thrust bearing set. So on this particular bandsaw, you're probably going to be better off because you have to loosen this lever here to adjust your thrust bearing forward and back. You're likely better off adjusting your thrust bearing before you adjust anything else. Okay? Because the moment I release this, everything moves. So, and front to back. So in this particular case, you're probably better off setting that. It's not far enough. That's maybe a bit too far. That's fine. So, because now I've set front to back, but I've adjusted my rotational adjustment on the front. So on this particular bandsaw, probably better off if you do thrust bearing before you do the rest. On my bandsaw, front and then the back, because it's a separate adjustment system. I don't touch left and right when I adjust back. So once again, depending on your bandsaw. You can hear it actually hitting parts of the blade, but it's not, it's still turning freely, so I'm happy with that. So on the bottom, you go through the same process. Try and get rid of most of the dust, because they can actually sit under your guides and so forth, and they can make the adjustments a little bit tricky. So I'm going to go once again, and the bottom one is usually harder to see. Okay, so I'm hitting, you can hear there, I'm hitting the thrust bearing before my side guides have moved far enough to be a millimeter behind the gullet. So they're too far back. So if I'm not mistaken, this thrust bearing is a separate adjustment. Okay? So where everything here happens on that same rod here, this one is separate. So you can actually adjust the thrust bearing at a later point. So I'm going to then go forward until I'm a mil back from and it can be tricky to see. It can be really hard to see. It's probably why I do the top one first, just to get into the mood, and then I go and struggle at the bottom. Okay, make sure they're both tight. They need to be tight. So what can happen if this is not tight is it can move with vibration and move forward, and then you guys can hit the teeth on your, on your blade, and it can chip out your blade. And that's actually what happened with mine. So mine, it doesn't matter how tight I adjustment, it always moves. So what I actually did with my bandsaw is I put a, what do you call it? A washer, but the washer is offset. Spring washer. So I put spring washers behind mine, so now when I tighten it, it stays put. So got that. Now the thrust bearing. Okay, and that tightment screw is way back here.
This setup typically is only done when you put a new blade in.
When you do a new blade, or when you set up for specific purposes.
So your width of the blade will, eventually you'll have to make the adjustment.
So the problem is with the width of the blade, remember when this one's got the crown, so you want to support your teeth. So if I, so the distance of your blade on top of the crown, forward and back, determines where your thrust bearing sits, as well as how far your side guides are. Okay, so if I've got a blade here, so my back of my thrust bearing is in line where I set up is here. If I have a wider blade and I'm still wanting to support the teeth, the whole blade needs to move back, which means my position here needs to be further back. Okay, and then, but if you eyeball your teeth there, you can have consistency just behind, because irrespective of the blade, your teeth are generally going to be in the same spot. But I tend to adjust it every
It's
time.
only your top wheel that you can adjust in and out. Bottom
Yeah.
wheel you can't.
You can, but ideally not, because it's set in factory. So it's only the top one that you need to adjust. Okay, so I'm going to come around to your side, and I just want to check my alignment. Okay, so you can see here, oh boy, okay. Okay, so the thrust bearing is still too far forward. Still too far. Okay, that's where dust extraction and keeping your tools is useful. Keeping your tools clean. Hear the tap? Okay. That means I'm away from the thrust bearing in the back. Yeah. But this was supposedly, this was used, okay, for demonstrations a few months ago. Have a look at the position of the guides. Have a look. You want to use the flashlight? They're miles away. Okay? And that whole thing was loose. The whole thing was loose. So, and that makes it a dangerous tool. So we do, and now there's so much dust there that it's hard to set. Look, the fact that there's dust in the bandsaw is not a strange thing. Dust extraction on bandsaws are notoriously hard to do. Okay, much happier with that. Let's see. Still moves freely. And now I'll use it. But before then, you can see here, you've got a lot less flex than we had previously. So, and in effect, it's set up. Now we can have a look at the table and we can have a look at your fence. Now, fence, I never rip workpieces to final width or final length on a bandsaw. Okay, so with this being parallel to the blade, honestly, I don't care. It needs to be close because I'm ripping maybe 5 mil oversize, and if it gives me a cut that's 4.5 or 6 or whatever, that really it doesn't matter to me. So therefore, I'm not too worried. Where parallelism between the fence and the blade comes into play is when you're doing really thin veneers. Okay, so if you measure between your blade and your fence 3 mil because you're cutting a really, really thin veneer, you want it to be parallel to some extent, yes, then you do set them. But apart from that, I really don't bother with it. There's 3 screws here, which I am assuming, not knowing this particular fence myself, I'm assuming will allow you, you loosen the front one, you loosen the back one, and it pivots on the middle one, and you can adjust parallelism. Really, it's not, to me, it's not that much of a concern. The other thing that one needs to pay attention to is on this particular fence, you'll notice that the front or the corner that's the furthest away from where you work it is sitting on the top. Okay, there's a plastic screw that actually lifts it up, so it lifts off the top, and that's really just so that you don't damage the working surface with the fence when you work on it. So that's the main reason for that. Then the tabletop square to the blade, that can be important, especially if you're doing thin veneers. If you're doing a 3 mil veneer, there's no point in the top of the veneer being 3 mil and the bottom of the veneer being 4 mil. So you want at least from in vertical in its height to be as accurate as you can. So having the table at 90 degrees to the blade is advantageous. So this is how I did it when I started. And I chased my tail a lot, as you would do a square. If you can fit the square, you put it up against, and you check for light and you adjust. Okay, but blade flexes so much, and sometimes your blades also get a kink in it, so it's really, really hard to do it that way. So I don't do it this way. I use that electronic meter. Where's the gauge? This one. This I find is good enough on a bandsaw, but you need to have a reference. So sometimes this is 90 degrees, or this should be parallel with the bottom as well. Okay, so you can either use either or, because if I plonk this down there and I zero it, okay, that is square to what? Square to itself. So I have tried that at times. That's not bad. Okay, or you'll find that that is square. What is that? That's quite square, 89.9. So now I know that that is can be my reference. So I can now move that or zero it, and then see if that's 90 degrees and make the necessary adjustments. There is a different way of doing it. Any chance we can get power on this machine? So this one I got from Mr. Snodgrass as well. Yeah. what you do is you use a block of wood that you know is square. It needs to be square. Cool, thank you. Sorry. So it needs to be square in at least 2 directions. So 1 square edge and face. That's good enough. So you'll see, I marked it. Face and edge. Check it, that's square, no light. Okay. So now we are live on YouTube. We've just adjusted the settings, and I told you guys how badly it was adjusted. Now we're going to switch it on and see how well I did. Do be careful in regard to the quality of your blade as far as drift goes. Okay, thanks. When we prepared for the safety discussion and did the safety talk, we set up the 2 machines here, and I was doing test cuts and checking how well they work, and this one kept drifting. And I set it up, and it's not supposed to be drifting, and it was all over the place. It was literally all over the place. And couldn't figure it out, And then somebody, in passing, mentioned that, yeah, this is the machine and the blade that was switched on with the blade being tensioned, and it damaged the blade. And we looked at the blade, and it was missing every 3rd or 4th tooth was gone, and some of the set was bent out of as well. So unless you've got a relatively blade that's in a good nick, if it isn't, that could also cause you issues in the run. So do keep that in mind. Okay, so what do they say? Fire in the hole. Going to adjust this down. This one's got nice. It's got a brake, and the brake is connected to the power, by the way. Which is a nice feature, nice safety feature, because that's the one place that this is going to get you. While it's winding down, there's a lot of inertia in those wheels. So what was I wanting to do? Oh yeah. Hope this works. So one of the best ways to check if your table is parallel to the blade is you make a cut in a square piece of wood, and then you bring it around and see if the blade slots back into the slot. If it doesn't go back into the slot, your table is not square. Helps if you do a straight cut. And you bring that around, and that should slot in. Okay, so if it doesn't slot in, that means your table isn't square. And that's probably one of the easier ways to check it. And that's the bandsaw. So bandsaw is, if you remember the rules and you then apply it to your own example, you should be fine. While understanding that to some extent this isn't a precision instrument, but you can get it to work precise and well. But do apply the basic concepts to what you have in your own workshop, and you should be okay. Yeah. Was he here when we had that discussion? I don't think he was. So wider blades and thinner blades. So bandsaw is generally used a lot for resawing, but also cutting shapes. So if you've got curves and stuff, I made the hand plane and I was cutting the handle. That's mine, I shouldn't be using, what was that? No, that's that one. So let's say you want to cut a curve. So you've got a straight piece of wood, and now you want to cut there. if you have a very wide blade, the blade is going to sit in here and you're not going to make the turn. They call it making the turn. If you've got a narrower blade that runs there, you can make the turn and make the cut. That's one of the main reasons you would use a narrower blade from the tooth to the back of the blade, so that you can cut curves, and the narrower the blade, the tighter the curve is that you can cut.
What is the wide blade will offer you that the thin blade doesn't?
Keeping straight inside the cut. So a wider blade is better for resawing, because let's say I'm resawing, this one for instance is a good example. It's one of the, actually the other one, not this one, but this bandsaw's got one of the best resaw capacities for, let's say, the hobbyist type woodworker or semi-professional. So you can effectively resaw a plank from top to bottom here. Now you can imagine this thin blade running in that curve. It's going to be all over the place because you've got no support. Whereas a wider blade is made of a thicker material, thicker metal. You put more tension into it, a lot more tension in it, so it pulls it straighter, it pulls it tighter, but because of the length of the curve, okay, the back of the blade then references inside the two walls of your curve, and that also then starts acting as a guide. So that keeps the blade straight in the cut, so therefore you can resaw more accurately.
When you say resaw, what you're doing is you're splitting a wider plank into two narrow pieces.
Yes. Okay, not face-wise, width-wise. So
Would it be realistically even possible to, if I wanted to make my own laminate, to get it cut clean enough off a bandsaw that I could just glue the stuff together?
you can.
Do you get then specific blades with different cutting widths?
With different set, and then you would be looking at carbide tooth blades. So the finer, the cleaner the cut, the higher the quality of the blade, and you're starting to look at 2,000, 2,500 Rand a blade. Okay, so that's a thinner tooth, narrower set, and it also cannot be too narrow because remember, the set and the gullet are supposed to be removing your waste. And if you don't have that, it also heats up and then burns your wood. So you need to find that balance, but quality blades will allow you to do that. On my particular bandsaw blade, there's a video where a guy does a veneer cut, where he puts a piece of a light source behind his hand, and you can see these hands shine through the board. It's that thin a cut. Yeah. So it depends. If you can do a laminate, yes, or you can do a veneer, but your quality of your blade is very important there. Setup is really important because you don't want any drift at all, and then the width of the blade. So the reason I've got a wide blade is I also cut a lot of my joinery on the bandsaw. So instead of using a handsaw to do my bridle joints, I actually use the bandsaw to do my bridle joints. And the straighter I can keep the saw blade in the curve, the better. And that would mean a wider blade.
So for a setup to resaw boards like that, would you get a taller fence or use fingerboards or what to keep it as stable?
So there's actually two schools of thought. You have a higher fence, or you can put a secondary fence on this particular one. Put a board on. I think Craig has got a fence that's this high, specifically for resawing. So that's one school of thought. The other school of thought is you have it looking at from the top. Okay, you have a fence, and then on that fence you've got a dowel or something like that that sits here. You're looking at it from the top. So you're pushing your wood in this direction. Okay, and you can pivot your wood around that fence and stay in the cut. That's another option. So as you do the cut, you're not registering against the fence for the full length of the cut. You're actually just registering it around that pivot point. So if you see that you're drifting, you can actually move the plank and stay in your mark.
How do you keep it against the fence?
You don't use a fence. That's your fence.
What I mean is, how do you keep your plank that you're resawing against your reference?
By hand.
You just have to keep pushing it.
Yeah, by hand. So you put
Fingerboards or anything?
no, you can put Because a fingerboard, remember, if you've got a fingerboard here and here, you can't pivot. Because that will stop you from going that way, that one will stop you from going that way. You can't pivot. So a fingerboard you would use with something like this. Okay? So, but if the advantage of having something like this, let's say you have slight drift and it's going to one side. By the time you've pushed through your cut, you've gone way off your line. Okay? So what this allows you is to adjust all the time, but you need to develop a certain amount of experience to do it, and the bottom surface of your workpiece needs to be square, needs to be flat, because otherwise your whole workpiece starts going over the place. So the way I resaw is I move my fence out of the way and I actually resaw by eye and freehand. So I stand here, I've got my plank, and I push it through, and if I'm drifting, I'm constantly adjusting. So I use no fences when I do resaw. Yeah. Because remember, I'm rough processing. I'm not cutting veneers. Okay? And you probably wouldn't be veneering anything bigger than...
No, actually, I want to make, you know, like pretty large laminates, pretty thick, but we'll probably be using 5 mil.
So what do you use as a base? What do you use as a base? Like MDF?
No, it'll be maple modeling.
That you use as a veneer?
Laminate, make a laminate, thin block.
Okay, but then you're better off doing it like this.
Doesn't cut thin blocks about this wide.
Yeah, but then you put it through a thickness planer and then laminate, face laminations. You wouldn't do it here. You're just wasting your time. It's not an efficient way to do it.
Yeah, but how do you get it thin enough to thicknesses? I mean,
So what you do,
resaw it and then thicknesses.
so you resaw, thickness, and then laminate. And remember, if your stock is thick enough, you know there's no reason for you to laminate. Why would you want to laminate? It's because stock that is available isn't thick enough?
No, it has to be stable, dimensionally stable. So I mean, like if you're driving a tuning pin in under force, the wood can't split. If you drive it into any wood, a bunch of tuning pins in a row will split.
So you're not looking for a lamination, you're looking for ply lamination. So you do a cross lamination, okay? But that you can still do with a thickness planer, more accurately and quicker.
Quicker?
Yeah, much.
I thought this would be quicker.
Because remember, you've got this set, it's quite heavy. You're going to have a lot of ripple. You're not going to have a clean surface.
So I have to run it through thickness.
You're going to have to run it through a thicknesser anyway.
I've got the same sort of application, boat building.
Yeah.
So I want to have a 5 mil thickness plank, but it's over 350
Wide.
widest,
Yeah.
and then I can get through a planer.
That you
And
can't put
you've
through
got
your
to go and cut that to about an 8 or more because of the drift and because of the heat.
Yeah.
The planks I'm cutting are 3 meters long,
Yeah.
and it goes well for the first 2 meters, and thereafter it's a bugger. Putting on a table saw, you're wasting a lot of material, and you've got to turn it over. Your blade's not big enough.
Yeah. And also remember, your blade runs up like this. If you're hitting a grain that isn't necessarily dead straight, it can actually flex your blade out. So any resaw that you do, be it there or here, would need to go to a thickness planer to get it nice and parallel.
things like maple and mahogany are pretty uniform. And mahogany not so much, but usually it's pretty uniform on maple. So that should be pretty.
Will be uniform, yes, but your teeth are going to make ripples. You're not going to get a clean surface.
I mean, otherwise, isn't there a possibility of using a drum sander, I reckon?
Yes.
Instead of the thicknesser. If I can cut them thin
It's going to take you longer.
precise enough that it can go through a drum sander, maybe the other thing is
So a drum sander is in effect a thicknesser that uses a different method to get there. So I would rather go thickness planer and get where I need to be quicker than a drum sander. Your final finishes on either side, drum sander by all means, but a thickness planer is going to get you there quicker. Even a drum sander can give you snipe, for instance. So it gets you to the same place, just uses different methods to get there. But you want to cross-laminate. So how would you do the cross-lamination, though? Because there's your length here, okay? So you say your grain is running this way, okay? Now, to cross-laminate, you're going to have separate pieces of wood that you need to edge joint, correct? And then you laminate one on the other one. Thickness planer is going to get you there much quicker. Okay? And you probably, unless you have a helical head on your thickness planer that leaves you with a very good surface once you're done, okay, you'll probably find that a drum sander, in your case scenario, is probably the better option. Because I use a thickness planer, it gives me a good surface which I still hand plane when I'm done. Whereas in your case, you want, the moment your stock comes out of the machine, you want to be able to have it to a point where you can laminate it.
I know it's a bit off topic, but what's the minimum thickness? I know my JPT 260 can do 6 mils at the thinnest, but the drum sander, how thin can it go?
Depends on the drum sander. I'm not sure. I don't have one and I've never worked on one, so I wouldn't be able. So they've got the ex-minister one here, and they should be able to give you its specs. But these, you probably would have this come out of the same lumber, piece of lumber, which you cross-cut in sections and then side laminate, because that ensures that it coming out of the same piece of lumber, that its movement properties is going to be as close as you possibly can for that section of your lamination. Although, even in the same board, movement's not always the same, depending on the species.
Multiple layers, so I think imperfections aren't really a problem because they're sort of mitigated by the fact that you have so many layers.
Aren't you better off just buying it?
Not really. I mean, I could buy it, but that would defeat the purpose of making.
Yeah, the problem is one needs to find the balance between making it yourself, spending the time doing it, and buying it, and what the time costs you to make it yourself versus what it costs you to buy. And remember, the guys who make it at much higher spec than you probably could be making it yourself.
That's true, but I mean, part of it is a learning process.
True.
It's to understand it, and to buy the material to experiment with it is not cost effective. To buy it to use it in a job is cost effective, but then you need the skill to use it in the job. So making it will teach you about material. Give you enough material to experiment.
Yeah and no. So there's really different opinions about it. For instance, me being a commercial furniture maker, there's no point in me making this.
But also remember, I have to import the stuff from Canada. It's not cheap. And when I say not cheap, I'm talking about whatever you think wood is expensive.
Time-wise, time and material-wise, making it yourself, it's not going to cost you less. No, agree. If you do it for that particular purpose, then do it. But if you do a cost-for-cost comparison, when you take the amount of time and the amount of waste in materials and the amount of materials you're going to end up wasting in experimentation, okay? If you're talking from a cost and time perspective, it's going to be much easier just to buy it.
No, I understand that. I've got no interest in just buying.
That's
I would have.
horses for courses.
If it was cheap, I would have, but it's not. It's
Yeah.
one of the most expensive pieces of meat you can get.
News to anybody who sits here, if you're going to do woodworking in any way, shape or form, it's never going to be cheap.
I'd rather spend the same money but learn something along the way.
True.
Just go and buy the high quality stuff and mess it up because I don't understand.
But how often would you need it?
Frequently.
Okay? But then again, once you know how to make it and you understand the materials and so forth, and do remember that you making it yourself, understanding the end product is not necessarily going to be the same as buying it. They don't use the same species. They don't use the same glues. So you have all of those considerations you need to keep in mind. But, look, I want to make an end grain chopping block because I want to know how to put the thing together. Okay? I made a kitchen trolley for a lady, this big, this wide, and it was end-grain tabletop. Will I ever do it again? Never. So if anybody asks me to do that kind of tabletop again, there are commercially available guys who do it. By all means, go and buy it from them. Because I don't have a drum sander, so I made 4 end-grain chopping blocks, separate ones, which I flattened. Then I put them together, which I flattened again, and then I put it on top of the table. Okay? And how did I flatten it? With a low angle jack, because I don't have a drum sander. So never, ever, ever again. So I've gained the experience the same way you would like to. So there's definitely room for gaining that experiencing and experimenting and knowing what goes into being able to have something like that. But when it comes from a commercial point of view, let's say you do pianos. Let's say you've got 5 pianos, you need the same material. I'd much rather buy it before I make it.
Ultimately, if it was for any iron restoration, I would buy it. But if it's for a project piano that I'm restoring for the sake of experience, then I'd rather make it.
Yeah, true. Yeah.
Because it's not. This isn't Europe, where if you wanted to, you could just take a 5-minute drive to the nearest piano factory and go learn how to make the stuff.
True, but likely in those cases as well, you'll find that they buy it in from a central manufacturer as well. Very rarely would they make it themselves. So it's really a case of what you'd like to learn, the amount of time, effort, and sometimes blood, sweat, and tears you'd like to put into the process to learn.
The difference in a commercial setting, they're working with preconceived expectations, because they know what material quality they're working with, and they know what the expected outcome is, and the process is the same over and over. So they don't have to understand anything about the product they're working with to get a result. They're working with certain quality control.
Yeah.
So I'm working with immense variables. So for me to have a better understanding of the material is more important than for the guy actually building the piano.
Yeah. True. So what is true for me may not be for anybody else. And as a result of that is we learn our own lessons and we experiment with our own things. It's like, let's say you guys use hand tools, okay? You would come to the shop, you would buy yourself a jointer, and you would use the jointer to join your boards. Me, I make the blade, I make the jointer out of wood, and I use my own handmade jointer. We come to the same conclusion. How we get there is different. Or in a commercial, I've made furniture using only hand tools. Takes a long time. I bought myself a jointer. So even though I can joint by hand, and I know how to do it, and I can actually do it more accurately than I do with a machine, if I'm doing a dining room table and I'm doing 6 or 7 planks like that, I go to the jointer. Although, if I don't get it nicely off the machine for a start, I will put it in and I use the hand jointer to get it to where I want it. What, my 8-inch jointer. 8-inch, it was a Woodsman. It was still one of the lines that was sold by Austria. One of the older machines. No, it's not industrial. All my stuff is 220s.
Are you good with jointer setups?
Yeah, but jointer setup is easy. It's like fall out of a tree. It's really easy. Look, you need to get your height on your outfeed table right so that you don't take too big of a cut. You need to get your blades parallel to that. You need to get your infeed, outfeed table coplanar. And then your fence doesn't even need to be 90 degrees.
I just can't, for the life of me, I can't get a board over that thing nicely. If I try to take a beach board over that thing, this thing's like jumping over.
Yeah, so your cut may be too deep.
Even if I try and do a shallow cut, and I get a lot of chip out, like not chip out, people like chattering on the board.
Then your blades are blunt. Could be, yeah. How long have you been using it without sharpen?
The set of blades I put on there were brand new, in fact, and it was doing that from the start.
Could be too deep.
I set them up myself, and I thought I did a pretty good job, but I still don't.
So you know on your outfeed table you don't adjust that on the fly. Eh? That's a once-off adjustment. You leave it. Your depth of cut is set by your infeed table. So
I haven't adjusted the outfeed.
that's too deep. It's likely too deep a cut then.
260 is the way I got it.
We effectively done with the setups. So yeah. So everybody here, thank you for coming. Guys online, thank you. We hope to be speaking to you guys online. Come to the hardware center. We're constantly working on courses. Next one we're doing, am I allowed to announce it? It's the end of next month. So the end of next month, we're doing one on shellac, how to prepare, how to use shellac. I'm going to do a presentation. That's going to be more almost a theoretical kind of course. So that's me standing in front of the class rather than having to move around the machines. And for the guys who've missed it online, you weren't able to see everything we did here, you're more than welcome to contact me through my website. Send me through the contact page. My details are there. If you have any questions, you're more than welcome to ask. I do on-site training as well, so if you'd like to book some training in my workshop, we can do that. We have discussed being able to put a camera onto a tripod and move around and then show you more details, so for the hands-off stuff. So it was nice to have you with us. Join us again, and we'll see you online or in the shop.